In this example, we have a body on which three forces act, F1, F2, and F3. These forces have a special property that their line of action intersects at one point, in this example the point 0. As we have already learned, such forces are called concurrent forces, and as we have already also learned, we know that these forces can be added by the force polygon. But how can forces be added which are not concurrent and which do not intersect in a point? To do this, we use the same procedure as in the previous slide. With the same magnitude as the force F1, we create two mutually cancelling auxiliary forces at point 0. Now we move the force F1 along its line of action. As we know from lesson 1, we can do this because the body is a rigid body. We now see that a couple with a distance L1 has formed. We can describe this couple as the moment M1. The same procedure applies now for F2. We form the two auxiliary forces at point 0 and move the force F2 along its line of action. Now we replace the couple by the moment M2. For F3, also the same procedure is applied. We form the auxiliaries and replace the couple with the moment M3. Now we have three concurrent forces at the point 0, F1, F2, and F3, and the three moments M1, M2, and M3. Since the forces are concurrent forces, we can now use the force polygon to form the resulting force. As we already know, we can arrange the force polygon in any order. So we can now draw the force F1, followed by the force F3, and finally the force F2. And thus, we have determined the resulting force Fr. Now we have to add the moments. For the resulting moment, we need the sum of all moments. So Mr equals M1 plus M2 plus M3. Since M1 is clockwise, its value is negative. M2 and M3 run counterclockwise, so they are positive. So we can now write Mr equals minus F1 times L1 plus F2 times L2 plus F3 times L3. So we added the three non-concurrent forces and replaced them with a resulting force and moment at the point 0.